the AI model that runs entirely on your PC. Meta just released a 30 billion parameter AI model that can plan, code, and run tools completely offline on a single graphics card, and almost nobody outside the AI community is talking about it yet. In the next 10 minutes, I'm going to break down exactly what Muse Glimmer is, why Meta built it this way, how it compares to the cloud-based models you already use, and whether it is actually worth downloading on your own machine. If you have ever wondered what happens when a serious coding and agent model leaves the cloud and moves onto your desktop, stick around, because this one changes the conversation. Let's start with the basics. Muse Glimmer is a new open-weight model from Meta Superintelligence Labs. It has 30 billion parameters, which puts it in a strange middle ground. It is far smaller than the giant frontier models running in data centers, but it is large enough to handle serious work like writing code, debugging errors, using external tools, and reasoning through long multi-step tasks. Meta built Glimmer by distilling it from a much bigger model called MuseSpark, then refining it with additional training focused specifically on agent behavior. In simple terms, they took the knowledge from a massive model and compressed it down into something efficient enough to live on your laptop or desktop. Here is the number that should catch your attention. A 30 billion parameter model would normally need more than 55 gigabytes of memory to run at full precision. That is completely out of reach for almost every consumer computer on the planet. Meta solved this by compressing Glimmer down to roughly 4-bit precision, which shrinks the memory footprint to under 20 gigabytes. Suddenly, a model that used to require a data center rack fits comfortably on a single consumer graphics card, or even on a Mac with enough unified memory. That is the entire point of this release. Meta is not trying to beat the biggest cloud models on raw intelligence. They are trying to make a genuinely capable agent model that lives entirely on your device, with zero network calls, zero per token billing, and zero data leaving your machine. Now let's talk about speed. Because a smart model that responds slowly is useless for real agent work. Meta paired Glimmer with something called speculative decoding, using a smaller companion model known as a drafter, built on a technique called deflash. Normally, a language model has to generate one word at a time, checking its own work at every single step, which is slow. The drafter model's job is to guess several words ahead of time, and then the main model quickly checks whether those guesses were correct. When they are right, which is often, the whole system moves several times faster than normal generation. Some early testing shows Glimmer decoding roughly 3 times faster thanks to this trick. That speed boost matters enormously for agent tasks, where the model might need to take dozens of steps in a row without losing your patience. So what can Glimmer actually do? Meta designed it around 3 core skills that matter for real agent work. The first is end-to-end task completion, meaning the model can take a goal, break it into steps, write and debug code, and carry a multi-turn task through to the finish line without constant hand-holding. Meta tested this using benchmarks like SWE Bench, which measures real software engineering tasks, along with deep search QA and other agent-focused evaluations. The second skill is reliable tool use. Glimmer is trained to call external tools and functions with precise, structured requests, even across long workflows where earlier context needs to be remembered accurately. The third skill is multi-step reasoning, which means the model can hold a plan together across a long, complicated task instead of drifting off course or forgetting what it was trying to do 5 steps earlier. One detail worth highlighting is how Meta handles mistakes. Instead of freezing up or giving up when something goes wrong mid-task, Glimmer is built to diagnose the error and retry. Similar to how a human developer would notice a bug, figure out what broke, and fix it rather than starting over from scratch. For anyone who has used an AI coding assistant that gets stuck in a loop or gives up after one failed attempt, this kind of built-in recovery behavior is a meaningful upgrade. Let's talk about context and language support, because these numbers are genuinely impressive for a model this size. Glimmer supports a context window beyond 120,000 tokens, which means it can hold a large codebase, a long document, or an extended conversation history in memory while working. It is also trained across more than 100 languages, so this is not an English-only tool. And for developers who want more control, Glimmer includes adjustable reasoning strength, with settings ranging from low to extra high. You can literally tell the model how hard to think before it responds, trading speed for depth depending on whether you are doing something simple or something genuinely difficult. Now here is where it gets interesting for the hardware side of things. Because Glimmer is open weight under the Apache 2 license, major hardware companies jumped on this almost immediately. NVIDIA published guidance for running Glimmer locally on GeForce RTX cards, as well as their DGX workstation lineup. AMD published their own benchmarks showing Glimmer running at usable speeds on their Ryzen AI Max processors and Radeon graphics cards. This is a genuinely rare moment where a single model release gets simultaneous native support from competing hardware makers on day one. And it signals that Meta is serious about pushing local AI into the mainstream rather than treating it as a side project. So how does this compare to the giant cloud models you are used to? Let's be honest about it. Muse Glimmer is not going to outthink the largest frontier models on the most difficult reasoning problems in the world. That was never the goal. What it offers instead is something those cloud models cannot: complete privacy. Because nothing you type ever leaves your device, zero ongoing cost. Because there is no per token bill once you have downloaded it, and full availability even without an internet connection. For developers working on proprietary code, for companies in regulated industries like healthcare, finance, or defense, and for anyone who simply wants a private coding assistant that does not phone home, that trade-off is extremely compelling.